So provide the basis for making inferences about the future. Inferences is the noun of inferential. So in order to make some predictions about the future, you have to use basic statistics or understand basic statistics and descriptive statistics as well. Also, basic statistics will provide the foundation for assessing something called process capability. We will talk about it tomorrow, inshallah. Also, it will provide a common language to be used throughout an organization to describe certain processes. Otherwise, all the description we have will be just KPI as achieving or not achieving. But if you want to give some insights about this KPI, you must say that on average you have X, the median is Y, we have a variation, a large variation or a narrow variation. So this is something very good to be used as a common language inside a certain organization. When all the organization understand only basic statistics, I'm not requiring that all of the people understand deep mathematics and statistics. No, just basic statistics. What is mean? What is median, standard deviation, and so on. This will create a common language and will make the communication in the organization more and more smooth and more productive in comparison to just saying that the waiting time now is not achieving target or the turnaround time now is less than 40 and so on. And that's it. We don't have any other information. But if we can elaborate on this more and more, we can get more and more insights about this KPI, not just make it a binary variable, whether I'm achieving, not achieving KPI. So if you do not achieve, what are the benefits for me? I can speak, but if I make some in-depth analysis, I will begin to understand why this KPI is not achieving the target, for example. So in business, the leaders or the management will not be satisfied with the attitude of just this KPI is achieving target. Thank you. Or not this KPI is not achieving target. Thank you. No, in both cases, they will ask a questions. In order for you to answer their questions, you have to know some sort about basic statistics and data analysis. Otherwise, you don't have something to tell them. One of the most important aspect or pillar in data analysis is to understand the difference between sample and population. Population simply are all the area under study or all the items that have the property of interest. I will give you an example. For example, as a quality improvement officer, I need to improve the waiting time in the outpatient. For example, just for example. Okay. So waiting time in the outpatient, it means I'm collecting data about the waiting times of patients in certain time of. Please make sure that your mics are turned off. Please. If you are new to our session, please, you are not allowed to turn on your video or turn on your mic. This will result in miss and result in interruption, and I have manually to go to the participant list and turn off your video and turn off your audio. So please make it easy for you and me and stick to this rule. Please keep yourself muted and keep your video turned off, please. Also for your privacy. So population in this example means that I need to measure all the waiting times for patients I have seen during, for example, the last 3 months. And on average, each month, my hospital receive or see about 5,000 patients. So I need now to collect the data about, if I multiply 5 by 3, we have 3 months. I need to measure or I need to study 15,000 waiting time. Is this something possible? Is this thing is possible? Can you collect data about 15,000 patient? Each patient has a waiting time, for example. Or is this something easy or something applicable? No. Thank you, Maria. This is something not applicable because you are trying to measure your whole population. And the 3 months time frame I used, just an example. Maybe you are interested in a year, for example. So you cannot just go and measure the waiting time of every patient your hospital will see in a year. This is completely unapplicable, completely unlogic. Yes, I need here sample. I need to take a sample. Sample, on the other hand, is a significantly smaller subset of the population, smaller subset, significant, yeah, significantly smaller subset of the population, used to make an inference. I will use the sample to represent the population, but on condition. The condition is the sample really must be representative of the population. Your sample must really be representative of the population, something we will speak about, inshallah, in a minute. No, I will take a stratified sample. In data analysis, usually we'll take a random sample. It will be sufficient. But if your population is needs strata, it's okay. You can go ahead and take a stratified sample. But as long as your population is homogeneous, a random sample will be sufficient. This is for dua quotation about stratified samples. All of the smokers in Egypt can be population. Yes, for sure. Another example. Excellent. I cannot get data about all the smokers in a certain. It's impossible. Millions. I need only take a sample. Okay, dua. So it's okay in statistics to rely on a sample, in order to infer for the population. On condition. On condition. The condition is your sample needs really to be representative of the population. Yes, because it may be biased or it may be unrepresentative. For example, the example of the smokers, my sample may incorporate males much higher than females. It means that the females was not represented well in my sample. So the issue of whether my sample is representative of the population is a very popular question. I have been asked a lot, whether in Lean and Six Sigma courses or data science and machine learning courses or data analysis courses and so on. So I will make it very clear for you, how can you make a representative sample, or how can you make your sample really representative of the population, as you can see. So how to take a sample which is really representative of the population. We have 3 criteria that must be met in order to have a representative sample. And by the way, when we speak about sample versus population, we have two parallel worlds. The first world, which is my course is upon it, is business management. You are working in a hostel or working in manufacturing, you are working in certain industry. And the second world is research. So please don't mix, or please distinguish between sampling in research, because this is something I have faced a lot in my courses from participants who have done Master of Science or have done PhDs or are they pursuing right now. They are mixing things altogether. They think that what they have been taught during their research methods is also applicable to business and vice versa. No, no. There is a huge difference in statistics between sampling in research. You are doing Master of Science or doing a PhD. It's have its unique characteristics, and sampling in business. You are working in quality, you are working in nursing, you are working in manufacturing, you are working in bank, and you are doing sampling. Because this will always make some confusion. These are two completely different things. Sampling in research have its unique rules, and sampling in business have also its unique rules. So please don't make up things, or don't mix things all together. So if you are coming from academic background like myself, you have pursued Master of Science or PhD, or you are preparing right now, Sampling in research a thing, and sampling in business in completely other thing. Huh? Because we have two different scenarios here. As a researcher or Master of Science or PhD student, sometimes your research will incorporate things that did not or have not been measured altogether before worldwide. And here your population will be for us in statistics unknown. You have an unknown population. You cannot even count your population. But in my example, when I'm working in a hospital or working in manufacturing plant or whatever the place, no, the population size for me at least is known. I know that I'm receiving per month 5,000 patients. I know that I am producing per month in this manufacturing plant 100,000 units and so on. So there is a lot of differences between them. So please distinguish between this. Our course is concerned with the business sampling. It means you have some sort of data which is already collected, whether in manual papers, in Excel sheets, in ARP, in SQL Server, and you know the population size. We are not speaking here about research. This is not a research methods course. Huh? So just to make this clear, because this is thing and its rules, another thing have its own rules. Okay, so I'm now speaking about how to make a sample that represent the population in business. First, sample size. There is a lot of ways in statistics by which we can determine our sample size. For example, there is mathematical and statistical equations in which you can input your population size and you get your sample size. We have some rules. If your population size is 100,000, you will take X. If your population size is a million, you will take Y. Population size is 1,000 or more. We have certain tables for this. I think we don't have time to speak about this in more and more details, but we have tables, we have calculators, we have if statement rules, which is widely used in statistics. Just give me your population, and based on a table and based on a rule, based on equation, I will tell you your sample size. So this is very simple thing. Once you have equation or the tables I talked about. Some of these tables are only sufficient or only used in research, and some of these tables or some of these equations would only apply in business. Again,